Download this code from codegive.com, link in the description below. Okay, let's break down how a Kodiak Canvas 10x10 cabin lodge tent, and similar tents in general, handle high winds, focusing on design features, setup techniques, and real-world considerations. While I can't provide a code example directly related to tent stability, that would be more in the realm of structural engineering simulations, I can give you a comprehensive overview of factors that influence wind resistance and strategies to maximize performance, along with some pseudo-code examples to illustrate decision-making processes related to setting up and maintaining your tent in windy conditions. Understanding the challenges of high winds on tents. High winds exert significant force on a tent. This force can manifest in several ways. Direct pressure. The wind pushes directly against the tent walls, trying to flatten them. This is the most obvious and immediate effect. Larger surfaces, like the walls of a cabin tent, catch more wind. Uplift. Wind flowing over the top of the tent creates a lower pressure zone, pulling the tent upwards. This is similar to how an airplane wing generates lift. This force is particularly dangerous because it can pull stakes out of the ground. Shear. Wind blowing across the tent can create shearing forces, trying to twist or distort the tent's frame and fabric. This is especially problematic with non-symmetrical tent designs. Buffeting/oscillation. Gusty winds cause the tent to shake and oscillate, putting stress on seams, poles, and guy-out points. This repeated stress can lead to fatigue and eventual failure. Debris impact. High winds often carry debris, leaves,